In this video, we are going to be doing number 66 on page 76 of the AP Physics textbook. In the figure, a spider is resting after starting to spin its web. The gravitational force on the spider is 0.15 newtons down. The spider is supported by different tension forces in the two strands above it, so that the resultant vector force on the spider is 0. The two strands are perpendicular to each other, so that we have chosen the x and y directions to be along them. The tension Tx is 0.127 newtons. Find A, the tension Ty, B, the angle the x-axis makes with the horizontal, and C, the angle the y-axis makes with the horizontal. So this one is actually pretty similar to the traffic light problem and the bag of cement problem. I'm going to switch it around a little bit from how they did it in the book, so it makes more sense with force vectors and what we're doing in class. So this dot is the spider. Its weight is 0.15 newtons. And I'm going to call this tension A. And here's angle A. And then this is tension B. And here's angle B. We also know that tension A is equal to 0.127 newtons. So like previous problems of the sort, we know that in order for the spider to be stationary, the x components of the two tensions have to be equal to each other. So TBx is equal to TAX, which translates to TB cosine of angle B. And we know that TA is 0.127, so 0.127 cosine angle A. So we know that. We also know, again, in order for the spider to be stationary, the tensions in the added tensions here and here have to be, in the y direction, have to be equal to the weight. So we also know that TBY plus TAY is equal to 0.15. And again, we can translate that to TB sine of angle B plus 0.127 sine of angle A equals 0.15. Now you guys may see an issue here. The issue, we have two equations, but we have 1, 2, 3 unknowns. We're leaving some important information out. We know that these two tensions are perpendicular to each other, so that angle A plus angle B is equal to 90 degrees. So we know that angle B would be equal to 90 degrees minus angle A. We can use that information to help us out. Based on our trig identities, we know that TB times the sine of angle B will actually be the same as TB cosine or based on what we just figured out, of 90 minus angle A, plus 0.127 sine of angle A is equal to 0.15. We can also plug angle B in here so that we have TB Oh, and I just realized this should be sine here. My bad. Okay. Now, one thing we should know from our trig identities is that the cosine of 90 minus the angle is equal to the sine of that angle. So we can switch this. I'm going to write it down here to say that TB sine of angle A is equal to 0.127 cosine of angle A. And again, the same thing applies here. The sine of 90 minus the angle is equal to the cosine of the angle. So TB cosine angle A plus 0.127 sine angle A is equal to 0.15. So this helps us out quite a bit. Now we have two equations and two unknowns. Now, so we just have to solve a system of equations. And let's see, what should we do? I solved this equation for TB. So TB is equal to 0.127 cosine angle A over the sine of angle A. Now I'm going to plug this into here so that we get 0.127 times cosine angle A over sine angle A times the cosine of angle A plus 0.127 sine angle A equals 0.15. Now let's simplify this. Now we have to figure out what will be best in terms of actually solving for angle A. So it took me a while to figure this out, but after a while I realized that if I multiplied both sides by sine, you would end up with one of the Pythagorean identities. So over here, you actually end up, remember, cosine squared plus sine squared is 1, and you can factor out the 0.127. So again, that would look like and then this just turns into 1. So you have 0.127 equals 0.15 sine times angle theta. And if you solve for angle theta, or theta A, you get 57.85 degrees. So that is one of the things that we wanted to find. Then, so that was part B of the problem. Part C is also pretty easy to figure out. because for that you want to find angle B, and angle B is just 90 minus angle A, so that's 90 minus 57.85, and you get 32.15 degrees. And then part A was to figure out tension B. And we actually had this equation for tension B. So tension B is equal to 0.127 cosine angle A divided by the sine of angle A, 0.127 times the cosine of 57.85 divided by the sine of 57.85, and you should end up with 0.08 newtons. So those are our three answers.